scholars, a quick video on the average rate of change of a function. First, the definition is given by the average rate of change of the function f of x over the interval a comma b is given by average rate of change f of b minus f of a over b minus a. Don't get intimidated. As I mentioned in the classroom, this is just the slope formula practically. Is the output when the input is b, so that would be, let's see, if this is x sub 2, that would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Indeed, rise over run, the flow formula. I prefer to use the sine delta, meaning change, the change in y over the change in x. For example, let's see. Okay, so indeed the average rate of change is just, as I said, delta, the change in output over the change in input, delta y over delta x. Okay, so let me stop here, give you some, let me just move here a little bit. Okay, so let's go ahead and do a couple of examples. Let me first stop sharing this. Okay, so let's go ahead and find the average rate of change of the function negative x squared plus 3x between negative 1 and 4. We can just build the xy table. We're going from negative 1 to 4. So let's go ahead and find the value of the function when the input equals the number. So we have the opposite of the input square plus 3 times the input. So let's see what we have. When the input is negative 1, negative 1 times negative 1 is 1. Opposite 1 is negative 1. 3 times negative 1 is negative 3. Negative 1 minus negative 3, negative 4. The input is 4 here. This will be 16, negative 16 plus 12, 4. It will be negative 16 plus 12, which is negative 4. Okay, so what do we have here? We go from, make sure I wrote this properly. Yeah, so we go, what's the change in x? It will be delta x, 4 minus 1. So let me just do it properly. The average rate of change is going to be change in y over change in x, minus minus. So we went from negative 4 to 1 minus 3 minus 4. Okay. Went from that to negative 4. Then here we went from 4 minus negative 1. So this will be plus plus. That will be 0 over 5. So the rate of change is 0. Okay, I was expecting something different. So that's one example. Let's try another one. Let's say this other example. F of x equals opposite of x cubed plus 5 from x equals negative 2 to x equals 3. Once again, let's build the xy table. So we are going from negative 2 to 3. We're looking for the output opposite of x cubed plus 5. Hopefully this one won't be 0 anymore. So let's see what we have. When the input is negative 2, negative 2 cubed, that will be negative 8. Opposite negative 8 would be 8 plus 5, that will be 13. Here when the input is 3, 3 times 3 times 3, 27. It will be minus 27 plus 5, that will be minus 2. Minus 22. Okay. So now let's see, let's go ahead and find the average rate of change. It's going to be over the change of y over change in x. Minus, we're going from this and that. So the change in y is going to be what? Negative 22 minus 13. We're going from 13 to negative 22. So the change is y2 minus y1. We're going from negative 2 to 3. So the change in x will be 3 minus negative 2. Okay, so this puppy is what? That'll be 35, negative 35 over 5. And last time we check, this is going to be negative 7. And that's the average rate of change. And let's start this other example. F of x equals negative 6x plus 7 over the interval negative 4, 8. We're going from negative 4 to 8. Let's find the output. When the input is negative 4, this is would be, that would be negative 6 times negative 4, positive 28, positive 24 plus 7, that would be 31. And the input is 8, negative 48, negative 48 plus 7. This one would be negative 48 plus 7, negative 41. Okay, so now let's find the average rate of change, change in y over change in x, minus minus. So that would be, we are going from 31 to negative 41, so it's minus 41 minus 31 over 8 minus 4. Before we do the math, remember that the average rate of change is the slope of the secant line. And the slope, of course, is the rate of change. And look at this function. This function is a linear function of the form mx plus b, where the slope is negative 6. So this answer better be negative 6, if not, we're in trouble. Okay, so let's see what we have. Well, that would be minus 72 over 12. This is indeed negative 6. Okay, negative 72 over 12, negative 6. It has to be, because we're looking for the slope, and this is a linear function. If I'm going to look for the rate of change between negative 40 to 800, it should be negative 6. To 8,000, 80,000, we always get negative 6. Of course, because linear functions, the rate of change is always constant, the value m. Well, sometimes we don't have the actual function, we just simply have raw data, typical life scenario, real life. So let's see, let me take the same information we had before when I first opened this section. Oh, I just lost the share, sorry. Okay. Okay, so let's review this. Well, what we have here is that Y represents the years, and C of Y represents the cost of a gallon of gas. And then the data that was collected was from 2005, 2012. Let's say that if we are interested in looking what happens within the year 2007 and 2011, well, those are the only letters that, those are the only 2 points that we use. So in 2007, the cost of the 1 gallon of gas was 2.84, $2.84. In 2011, the cost of the gas was $3.58. Notice that we discard everything else, we just simply use these two. And back to basics, let me stop sharing. So now we just simply use that. So this minus that, or this minus that. So delta y over delta x, the cost of gas, of 1 gallon of gas went from $2.84 to $3.58. So the change was 2.58 minus 2.84 over 5 years, so 4 years. So from 2007 to 2011. This is 4 years, and my numerator is 2.58 minus 2.84. That will give me 0.34 cents over 4 years on average. If I divide that by 4, on average, the cost per gas was increasing because it's posted at a rate of 18, let's just say 19 cents per year between 2007 and 2011. And that would be it. Thank you.